Good morning, students. Today we are going to do the changing the magnitude of required force. We were doing about the machines, that these machines they perform following functions. Number 1, changing the point of application of force. Number 2, changing the direction in which the force is applied. Number 3, changing the magnitude of required force. And today we are going to do this, changing the magnitude of the required force. It is almost impossible to open metal cap of the bottle. Like if you have a cold drink bottle, it is almost impossible to open the metal cap of the bottle with our hand, as this requires a large force. A bottle opener helps us to remove the cap by applying a much smaller force on its handle. We apply a very small force on its handle, and the opener does a large amount of work, and the bottle opens. Then the nut cracker, the spanner, the jacks also help us in the same way. They let us use a much smaller force than we should need to use without these machines. So otherwise, to open a nut we require a large amount of force, but the spanner helps us to do it very easily. In other words, they magnify the force we apply. Magnify means multiply. We apply a little force and they multiply it a number of times and increase the force, make it larger, and the work is done. Next is changing the speed. When the wheel attached to the pedal of a cycle turns, it makes the cog wheel attached to the rear wheel turn much faster. This helps us gain speed. So when we are applying force on the pedal turns the cogwheel, which is attached to the rear wheel, which turns faster, and the speed is increased. Then types of machines. Depending on the basic principles on which they work, machines can be divided into different categories. They are: number 1, lever, inclined plane, wedge, screw, wheel and axle, and pulley. Though we have included the inclined plane in our list, it is not really a machine, as you will see. So first we are going to study about the levers. Lever is a kind of machine, and this lever is a rigid body capable of rotating about a point on itself. It is a rigid body which is capable of rotation on a point on itself. So this lever, it is just a rigid body which is capable of rotating about a point on itself. A rigid body is a body which does not change its shape when force is applied on it. Thus, a metal rod or a stout wooden stick is a rigid body. So this wooden stick is also a rigid body, and it acts like a machine. Why? Because it rotates on this point, and just by applying very little force we can lift a large amount of load. When such a body acts on a lever, it rotates or tends to rotate about some point on itself. This point is called fulcrum, which is represented by F. And the fulcrum of a liver is the point about which it can rotate. The stick resting on man's shoulder, and this figure 5.7, acts as a liver. It rests on the man's shoulder and can rotate about this point. Therefore, this is the fulcrum of the liver. So this stick, which is resting on the man's shoulder, it can rotate about this point, and this point is called fulcrum of the liver and is denoted by F. Then the force applied on the liver is called effort, and the point at which the effort is applied is called effort point. So the point where the force is applied is called effort, and this point is represented by the letter E. And the distance between the fulcrum and the effort from the distance between the fulcrum and the effort point is called effort arm. And this distance, if this is F, this is L, and this is E, the distance between F and E, that is the fulcrum and the effort, is called effort arm. And the distance overcome by the resistance overcome by the lever or any other machine is called load. And this resistance which is overcome by the machine is called load. And the weight of the bundle acts downward on the stick. This is the resistance overcome by the stick or the load. And the point on which the lever at which this load acts is called load point. And this point of the lever at which the resistance acts or is overcome is called the load. And it is called load point, usually denoted by the letter L. And this distance between F and L, that is FL, is called load arm of the lever. And levers are grouped into three classes or types on the basis of the relative position of the fulcrum, effort, and load. And this lever can be grouped into three types depending upon the relative position of the fulcrum, effort, and load. So, relative position means in first case the fulcrum is in the center, second case load is in the center, third effort is in the center. So the levers are of three types. And the distance between the fulcrum and the load point is called load arm, and the distance between the fulcrum and the effort point is called effort arm. And if the two constituents on the two sides are interchangeable, so these two constituents, they are interchangeable, and the class of the lever does not change. If we change only the two, like we change load and effort, we put effort here, load here, the class of lever will not change. So this much for today.